This will be a round 2 or round 3 question, right? So it's given that the decimal value of 100 factorial is written and converted into some other integral base v. Number of zeros at the end were found to be same as that of the original number. First, need to find the number of zeros in 100 factorial. So we know the concept that the number of zeros will depend on power of 2 and 5, because 2 into 5 is 10, so we need to find the power of 10 basically, right? In 100 factorial we need to find the value of 2 and the power of 2 and 5. So how can we find this? 100 upon 2 is 50, so there are 50 multiples of 2, multiples of 4, which is 100 by 4 is 25. Similarly, multiple of 8 will be 12, then 6, then 3, then 1. So we'll have 97 values here, and similarly for 5 it will be 100 upon 5, that is 20, upon 5 is 4, that is 24. So we have 2 raised to the power 97 and 5 raised to the power 24 here. So we can club 24 powers of 2 with 24 powers of 5 to get 24 powers of 10. So that means 24 zeros will be there in 100 factorial. Now, the number of zeros at the end when you convert something into base will depends on what. Let's say when you convert some number into base, for example, let's say we have 34. 34 is converted into base 2, for example. So we will divide this by 2, gives you 17, gives you 0. 2 divide by this, 8 gives you 1. 2, that is 4, 0, 2, 2, 0, 2, 1, 0. And you read it upside down, so your number will be 1, 0, 0, 0, 0, 1, 0. Now, you have 1 trillion zeros there at the end, right? So, why you are getting 1 0 at the end? Because this number is divisible by 2. So, when you divide this number by 2, it gives you 1 0. Remainder is 0, right? Similarly, if this number should, when this number was multiple of 4, for example, so you can divide this number 2 times by 2, right? So you'll get 2 zeros at the end, right? So the number of zeros when you convert something into some base will depend on how many times this number is divisible by the base in which you are converting this number. That means, again, we need to find that what is the power of 2 in this base, right? So like 34 has only one power of 2, so we'll have 1 0 at the end. So similarly, we need to find the possible values of v, for which you'll have exactly 24 zeros when you convert 100 factorial into some other base. So now 100 factorial is converted into some other base, and we need to find the number of zeros. So the value of v should be like this, that it should be a factor of 100 factorial, right? So that gives you number of zeros at the end, and the value of v should be like this, that you will get exactly 24 factors at the end. That means the power of the highest power in v of any number, any prime number, should be at max 24. So if you convert 100 factorial into its powers, so we'll have 97 already we have counted, so for 97 is there. Using the same concept, we can find the powers of 3 also, it will come out to be 48. Then 5 is 24. Then 7 will be 16, and so on and so forth. Right. Now, because 7, the power of 7 is 16 here, but we need 24 zeros, so we need to find those numbers which gives you power as 24, right? So we can say that after this we can simply rule it out, okay? Now, if you take an example, like v can be 5 also, right? So if 100 factorial when converted in base 5, it will give you 24 zeros at the end, because power of 5 is 24. Similarly, 3 is for 48 can be written as 3 square raised to power 24. So value of V can be 9 also, right? So similarly, this can be written as 2 raised to power 4 raised to power 24, and 1, 2 will be ruled out, will be left out, so that is not no use of me. So value of V can be 2 raised to power 4 or 3 square or 5 or any multiple of these values, right? Because the power in all these cases is exactly 24. Right, now what is the first question saying to me? The maximum value of V can take. So we can simply say that the maximum value is nothing but 2 raised to power 4 into 3 square into 5, right? Which is nothing but 720. So the answer is option A. And next is asking for the minimum value of V. So this is 16, this is 9, and this is 5. Minimum is nothing but 5. This is 720 and minimum is 5, which is option B.